in this problem, we're told that a certain mother has two children, and the problem tells us of a hereditary disease that can potentially be passed down from mother to child. Now we're told that the probability of the mother having the disease, the prior probability, is 1/3, and we're going to let this event, and we're going to let D signify the event that the mother has disease. We're also going to make the event CI, we're going to label CI the event that the ith child has the disease. And we're told that given that the mother has the disease, the probability of each of the children having the disease is 1/2, independent of each other. We're also told that if the mother does not have the disease, then the children cannot have the disease. So the probability that the children have the disease given that their mother doesn't is 0. Now, in part A of the problem, we'd like to know what is the probability that neither of her children have the disease. And to compute this, we're going to use the law of total probability. We're going to break this up into the probability that the mother has the disease times the probability that her children don't, given that she has it, plus the probability that she does not have the disease times the probability that her children don't, given that she does not have it. Now the prior probability of the mother having the disease is 1/3, and we know that if the mother has the disease, her children are independently of each other have probability of 1/2 of not having the disease. So the probability that both of them don't have the disease, given that their mother has it, is 1/4. 1/2 times 1/2, 1/4, plus the probability that the mother does not have the disease is 2/3, and we're told that if the mother doesn't have the disease, her children definitely do not. So this term here is just 1. And we have our answer, which is 9/12. Now moving on to part B. Part B says, knowing information about the elder son, can we deduce anything about the younger son? So given that the elder son has the disease, can we say anything about the younger son? Well, if elder son has the disease, then we know for a fact that the mother also has the disease, because if the mother did not have the disease, none of her children would have it. So if the elder son has the disease, the mother has the disease. And if the mother has the disease, we're told that the probability of the younger child having the disease is 1/2. So the younger child has probability 1/2 of having the disease. So knowing that the elder child has the disease brought the probability of the younger child having the disease to 1/2. Now, unconditionally, not knowing any information, the probability of the younger child, let's say that's child number 2, having the disease is, well, that's the probability that the mother has the disease times the probability that the younger child has the disease, plus the probability that the mother does not have the disease times the probability that the younger child has the disease, given that the mother doesn't. Now this is just 1/3 times 1/2 plus 0, which is 1/6, and we can see that the unconditional probability is not equal to the conditional probability. So knowing that the elder son has the disease increased the probability of the younger child having the disease. So the two events are not independent. And now moving to part C. In part C, we're asked to find what is the probability that the mother has the disease given that her two children don't. And again, we're going to use Bayes' rule here. So we get the prior probability that the mother has the disease times the likelihood of both her children not having the disease, given that she has it, over the probability of both her children not having the disease. So in the numerator, we have the prior probability, which is a third. And remember, again, by what the problem told us, we're given that if the mother has the disease, then the probability that her children don't, for each child is independent of each other with the probability of 1/2. So it's 1/2 that the first child doesn't have it, times 1/2 probability that the second child doesn't have it, independent of each other, so we can multiply those probabilities over the probability that both her children do not have the disease. Well, we computed this already in the first part, in part A. And so this was 1/3 times 1/4 plus 2/3. Let's verify. Yes, 1/3 times 1/4 plus 2/3. And so simplifying this expression, we get 1/9.